So like I said, 4 would take at least 2 days. We might finish today, we might not. We'll just find out. But factoring polynomials, part 2. We're just keeping on trucking in 4. So let's talk about quadratic form. An expression of the form AU squared plus BU plus C, where U is an algebraic expression, is said to be in quadratic form. The factoring techniques you have studied can sometimes be used to factor such expressions. So the ones we've used before, we're most likely going to be able to use today. It's just going to look a little different because our exponents are going to be bigger. Because like it says, U is an algebraic expression. An algebraic expression could be anything like that. So if you plug that into AU squared plus BU plus C, you're squaring that value, so obviously our exponents are going to be bigger. Okay? Does that make sense? But, like it says, we can use some of our old factoring techniques that we've used before. Any questions? Can we jump into some examples? Okay, I'll give you a little bit to write this. All right, so let's jump into some examples. So factor 16x to the 4th minus 81. That's letter A. Does anyone have any ideas of what I might need to do? Or where I could start? Based on past factoring techniques. Do we notice anything about our two terms? They're perfect squares, right? And they're being subtracted. So does anyone remember what this would be? Difference of squares. I can easily take the square root of 16x to the 4th. I can easily take the square root of 81. So those are two perfect squares. They're being subtracted. So I know it's a difference of two squares. Does anyone remember how to factor a difference of two squares? Start off by creating our parentheses. What goes in the first spot of each set of parentheses?
The variable.
Not quite. I mean, we will have a variable in that spot, but there's something else that goes with it. So remember how we find both those spots. We take the square root of that whole first term. So I'm taking the square root of 16x to the 4th. What would the square root of 16 give me? 4. What would the square root of x to the 4th give me? X squared. Because x squared times x squared would give me x to the 4th. Does that make sense? So 4x squared is going in the first spot of each of my set of parentheses. Does everyone remember that? We've seen that before. We've mainly dealt with it with something x squared, though, instead of x to the 4th. How do I find this second slot in each set of parentheses? Square root of 81. What's the square root of 81? 9. Put 9 there, 9 there. And then, how do I know what the signs are? One's a plus, one's a minus. Is everyone good with that? Now, can either of these factors be factored any further? See, some people shaking their heads no.
Yes.
Yes. Which one and why?
They both can be factored because square root. You can square root both of them, and you get because they're what is it called?
just said it earlier. I can
They're perfect squares.
perfect squares, right? I can only factor this right factor farther because it is a difference of squares. Do I have a formula for the sum of two squares? We do not. So I cannot factor that left one any further. So let's factor that right one. Just like we factored the first part of this. Create my two sets of parentheses. How do I find that first term in each set of parentheses again? Square root of 4x squared. What is the square root of 4x squared? 2x. How do I find the second term in each set of parentheses? What's the square root of 9? And then what are my signs? One's plus, one's minus. Does everyone see that?
Yes.
Once again, we want it to be in factored form, which means we want to keep factoring until we can't factor anymore. So can I factor anything else here? No, I cannot. So this would be my answer. Any questions on letter A? Don't forget about the difference of two squares. It's pretty easy to factor. You just got to take the square root, one's plus, one's minus. Okay? Can I erase and move to B? Letter B. 3p to the 8th plus 15p to the 5th plus 18p squared. Any ideas what I might need to do here?
Find the greatest common factor.
Find the greatest common factor. So looking at my coefficients first, is there a number that goes into 3, 15, and 18? 3. 3 goes into all three of those, correct?
Yes.
So I can factor out a 3. How many p's do they all have in common? 2. So I can factor out a p squared. Everyone good finding a GCF? So now I'm asking myself, 3p squared times what would give me 3p to the 8th? P to the 6th. 3p squared times what would give me 15p to the 5th? 5p to the 3rd. And then 3p squared times what would give me 18p squared? 6. Everyone's still good factoring out a GCF. Always, always, always look for a GCF right off the bat. You can factor out a GCF, go ahead and factor it out. All right. Can I factor any of these any further?
Yes.
Which one?
The ones in the parentheses.
The polynomial in the parentheses. How do I know I can factor that? It's similar.
It's similar to the factoring.
It's similar to my factoring from last semester, isn't it?
Yes.
Where I had quadratics that I was factoring, where it was p squared plus 3p plus 6, right?
Yes.
I just have bigger exponents, but I can still factor it the same way. What would go on top of my x puzzle? 6. What would go on the bottom? 5. So I'm looking for two numbers that multiply to give me 6, add to give me 5. Positive 2, positive 3. So I know I'm going to have a plus 2 and a plus 3, but what would go in the beginning of each of my set of parentheses? We'll have a p, but not just p, not squared. Let's think about it. P to the what times p to the what would give me p to the 6th. P cubed on both of them. Does everyone see that? Because if I FOIL this out, I'm going to have to multiply p to the 3rd times p to the 3rd, which would give me p to the 6th. And then plus 3p to the third plus 2p to the third would give me 5p to the third. And then 2 times 3 would give me 6. Any questions on that? Can any of those be factored any further? No, they cannot. There would be my answer. Any questions on B? Once again, we're just factoring until we can't factor anymore. We're still using our old techniques. Like I said, though, we're just dealing with bigger exponents. Okay? Any questions there? Can I move to the next example? Or next concept? Okay, the factor theorem. When dividing polynomials in the previous section, the examples had non-zero remainders, correct? We put our remainders over our divisor. Sometimes our remainder was just a number. Sometimes it was a polynomial. But whatever it was, we put it over our divisor, correct? Whenever we divided. Suppose the remainder is 0 when a polynomial f of x is divided by x minus k. So let's say we divided two polynomials and the remainder was 0. So that would mean us dividing our function by x minus k would equal some polynomial that we got, and then our remainder 0 would be over our divisor, correct? So if I have 0 over anything, that's going to be 0. So that pretty much just goes away to give me q of x. Does that make sense? For our remainder 0, we just get q of x. Because if we put our remainder over our divisor, 0 over anything 0, our polynomial plus 0 would just give me our polynomial q of x. Questions?
So the f of x divided by x minus k equals the same thing?
So if my remainder is 0 when I divide my function by the divisor, x minus k, and my remainder is 0, then I just get some polynomial. I don't have that fraction at the end of some number over my divisor. Right? Does that make sense?
So is the quotient from the first one going to be the same at the end?
I'm not quite sure what you're asking.
So f of x divided by x minus k equals
Yes.
q of x
Yes.
plus 0
Yes.
over x minus k equals q of x.
Yep.
So would the two q of x's be the same?
Yes, yes, yes. So this is just showing that if I have 0, so don't worry about this for right now. If I have 0 over anything, whether it's just a number or a polynomial, what do I get? 0. So that would equal q of x plus 0, right? And then q of x plus 0 would just give me
Q of x.
q of x. So that's what that is saying right there. So that q of x is the same all the way throughout. Okay? Is that what you're asking?
Yeah.
Yes. Where q of x is the quotient polynomial, our answer that we got when we divided. So therefore, f of x equals x minus k times q of x. So that x minus k is a factor of f of x. This result is summarized by the factor theorem. So we can essentially see if x minus k is a factor if our remainder is 0. So here's our actual factor theorem. A polynomial f of x has a factor x minus k if and only if f of k equals 0. So if I plug that k value into my function and I get 0, then I know x minus k is a factor of that polynomial. I know it might seem kind of confusing here at first, but Hopefully it'll help make a little more sense once we do some more examples. Everyone have this written down? Can I move on? Okay, I'll give you a little more time. Can I go ahead and move on? So example 5, letter A, determine whether x minus 2 is a factor of f of x equals x squared plus 2x minus 4. So what would my k value be in this case? Positive 2, right? I got that from this x minus 2, right? Because that's x minus k. So my k value is 2. So one way I can determine whether that is a factor of my polynomial or not is by direct substitution, by plugging my 2 in to my function. So f of 2. So I'd get 2 squared plus 2 times 2 minus 4. Is everyone with me? Just plugged my k value in directly into my polynomial. And now I'm just going to work that out using my order of operations. So what's 2 squared? 4. What's 2 times 2? 4. And then I still have that minus 4. What's 4 plus 4? 8. And then what is 8 minus 4? 4. So my f of k value is 4. So would this be a factor of x squared plus 2x minus 4 or not?
No,
Why not?
because it's a factor only if it is f of k equals 0.
Very good. Based on my factor theorem, a polynomial f of x has a factor x minus k if and only if f of k equals 0. So I found f of k to be 4, right? So since f of 2 does not equal 0, I know that x minus 2 is not a factor. Does that make sense? Everyone good with that? We plugged in our k value. We did not get 0, so it's not a factor. Everyone good with that? Can I erase and move to B? Letter B. X plus 5 is a factor of f of x equals 3x to the 4th plus 15x cubed minus x squared plus 25. What's my k value? Negative 5. So we could do direct substitution here, where we plug in negative 5 for x, so on and so forth. But we'd get really, really, really big numbers, wouldn't we? Another way we can do this is to just use synthetic division. So let's get a little refresher on synthetic division. How would I use synthetic division on letter B?
You're going to find the coefficient.
list out my coefficients of my dividend. So what are my coefficients?
3, 15, -1, and 1.
Do I need to account for a 0 anywhere?
No. Oh, wait, yes. For
Oh, yeah,
X.
constant.
I don't have that x variable, do I?
No.
What do we say our k value was?
-5.
-5. So bring my 3 down. What's -5 times 3?
-15.
-15. Do I add or subtract down that column? Add. What's 15 plus -15? 0. What's -5 times 0? 0. What's -1 plus 0? -1. What's -5 times -1? +5. What's 0 plus 5? 5. And then -5 times 5. -25. 25 plus -25? 0. What's my remainder? 0. So this is another way to tell if our x plus 5 is a factor of that polynomial. If you get a remainder of 0, then it is a factor of our polynomial. So in this case, I could say x plus 5 is a factor. Does that make sense? So on letter A, we could have used synthetic division if we wanted to. Letter B, we could have used direct substitution if we wanted to. That's just two ways to decide if it's a factor or not. That makes sense? So if you use direct substitution, plug your k value into your polynomial. If you get 0, it is a factor. If you're using synthetic division, if you get a remainder of 0, then it is a factor. If you get any number other than 0, it's not a factor. If you plug it in, get any number other than 0, it is not a factor. That makes sense. All right. Can I move on to the next example? Okay, example 6. Show that x plus 3 is a factor of f of x equals x to the 4th plus 3x cubed minus x minus 3. Then factor f of x completely. So do y'all want to use direct substitution or synthetic division? You want to use direct substitution? So my k value is what? -3. So if we're using direct substitution, I'm finding f of -3, which means I'm plugging -3 in anywhere I see x. Does everyone see that? Finding f of k. So doing all my exponents first. What's -3 to the 4th power?
-12 or no?
Nope, not quite. It's -3 times -3 times -3 times -3. What's -3 times -3? Positive 9. Positive 9 times -3. -27. And then -27 times -3. 81. Very good. What's -3 to the 3rd power? We just found it before we found -3 to the 4th. -27. What happens to these two negatives right here, the minus -3? Turns into a +3, and then I still have that -3. Is everyone with me still? What's 3 times -27? -81. And now I'm just going to add from left to right. Add or subtract. 81 plus -81? 0. What's 0 plus 3?
3,
3. What's 3 minus 3?
0.
0. So did I get 0? F of k equals 0?
Mm-hmm.
I did. So that shows me that x plus 3 is a factor. But, so that's the first part of my answer. That's me showing that x plus 3 is a factor. How do you think I could factor this completely? There are a couple of ways you could go about this. Anyone have any ideas how I should factor this? Can I erase all my work over here to the right? Do I have any GCFs on f of x that I could factor out right off the bat? Nope. I don't have a number that goes into 1, 3, -1, and -3 besides 1, correct? And they don't have any x's in common. How can I factor this? We talked about this method yesterday, the one that I'm thinking of.
Factor by grouping.
Factor by grouping. It looks like these first two terms have a common factor, and these last two terms have a common factor. So what would be the GCF of these first two terms?
X to the third.
X to the third. X to the third times what would give me x to the fourth? X, right? And then x to the third times what would give me 3x cubed?
3.
Plus 3. Everyone good with that?
Mm-hmm.
Okay, what would be a good common factor for those last two terms?
Negative 1.
-1. -1 times what would give me negative x?
X.
X. -1 times what would give me -3?
Negative 3.
Positive 3. Do we want something to match when we're factoring by grouping?
Mm-hmm.
Yep. Do I have something matching? Yep. So what's one of my factors?
X plus 3.
X plus 3. I already knew that based on what I did at the beginning, right? Found out that x plus 3 was a factor. But now I'm just finding out what the other factor is. What's the other factor?
X 3 squared plus 1 or minus 1.
X to the third minus 1. Does everyone see that? Can I factor either of those further?
No.
For sure?
Or the X to the third.
X to the third minus 1. How do I know I can factor that? Based on yesterday's notes.
Difference of squares.
Not squares.
Cube.
Cubes.
Difference of cube.
Are these both perfect cubes? X cubed and 1. I can take the cube root of both of them, right? So I know they are cubes. And it's a difference of cubes. So I'm going to be using my difference of cubes formula. So I'm going to be using my difference of cubes formula. A minus b times a squared plus ab plus b squared. Right? That's what we learned part of that yesterday. So what's my a value? X. We just take the cube root of x cubed to find our a value. To find our b value, we take the cube root of 1, which is 1. So a is x, b is 1. I'm just going to be plugging in to this formula right here. but I need to erase it to give myself some more room. So I still have that x plus 3 I need to account for. And now plugging in my a and b value to my formula, I get x minus 1 times x squared. What's 1 times x?
1x.
1x, or just x. And then what's 1 squared? 1. Can anything else be factored any further? No, it cannot. So here would be my polynomial completely factored. Does everyone see that? Any questions there? Now there is a little bit of a quicker method here in this case. Right off the bat, to see if my x plus 3 was a factor, I could have just gone ahead and used synthetic division. And that would have told me if x plus 3 is a factor, and it would have given me my other factor as well. So let's look at that real quick. I'm going to kind of go through it pretty quick. Our k value is -3. Our coefficients are 1, 3, 0, -1, -3. Bring down my 1. -3 times 1 is -3. 3 plus -3 gives me 0. What's -3 times 0? 0. And then what's 0 plus 0? What's 0 plus 0? 0. Once again, what is -3 times 0?
-3.
0. Now, -1 plus 0? -1. -3 times -1?
-3. Or
+3. And then -3 plus 3? 0. So, once again, that shows us that x plus 3 is a factor, because we got a remainder of 0, right? And then it says to factor completely. Well, I know x plus 3 is a factor. My other factor is actually right here with all my coefficients. Because remember, if we divide using synthetic division, that gives us our polynomial after we divide. So what's this coefficient 1? What's its variable with the correct exponent?
x to the third.
X to the third. 1 less than this x to the fourth up here, right? Do I have an x squared term?
No.
Do I have an x term?
No.
No, so I just have that -1. That's what we found earlier, right? Whenever we did factor by grouping. And then I could have factored that using my difference of cubes. So we did it 2 ways. This one probably would have gone a little faster, but that's okay. So you may just want to try using synthetic division right off the bat if you have a problem that asks these questions. Okay? Any questions about that? Can I move on to our assignment? Page 194 through 195, 32 through 50 evens. That's about 9-ish problems, I think. So make sure you get this written down. Does anyone have any other questions before I end the recording? Let's say this will be due Monday,
Do Tuesday.
I'll do Tuesday.
Monday we ain't got school, so you got school.
Due Tuesday, January 19th. On Canvas. Since we don't have school on Monday, you're welcome. Any questions before I stop the recording?